Hi again. We're now going to talk about milling machine tools. Yeah, tools used on the milling machine. This is the first one we'll talk about. It's a slot drill. It's 2 flutes, as you can see, and they come in 3 and 4 flutes as well, but two's the most common. And as you'll notice from the top view here, one of the flutes, one of the cutting edges here goes past the center line of the tool, and that means that it can be used for plunging into the material. So, yeah, hence the expression slot drill, because it can be drilled into a flat plate. Unlike a drill, these edges here are for cutting, so as well as plunging into the material, it can cut along at a depth and mill a slot. Okay, so slot drill. That's that. And the next one we're going to look at is slightly different. It's called an end mill. This is an example of a 4-fluted end mill. And you will notice on the top here, it has the 4 flutes, but none of them intersect the center line. And this means that it cannot be used for drilling or plunging into the material. It can only be used for milling. So if you have your component, say this is the component, you would have to start off the edge, plunge to your depth, and then mill along that way, and then go deeper, mill along right off the edge. Similarly, it can work on the top face. So again, starting off, touching on, milling, coming off, touching on, milling all the way, and then if you need to go deeper, come right off the edge, go deeper, and then mill again. So that's an end mill. End mill. That's a 4-fluted one. This is a larger one. It's got 6 flutes. You'll generally find the larger the diameter, the more flutes it's going to have. This helps distribute the forces. So obviously, there's more opportunities for a cut as this rotates, where it would be rotating slower. So it means that the cutting rate is the same. Next thing we'll talk about is this one. It's a ball nose cutter. I'll write that down. Ball nose cutter. And as the name suggests, it has a round end there. So it will mill across the top of a component and leave you with a nice round valley bottom, if you like. Can also be used in conjunction with a slot drill or an end mill to radius inside corners. So you can end up with and a flat and then round and back up. This being a material. The next cutter we'll talk about is this one. It's a radius cutter, and it does sort of the opposite of the ball nose cutter. So radius. And it will allow you to form outside radiuses, radii. So you can have components with that profile. And then, obviously a combination. You could go flat, radius there, flat, etc. Yeah, basically one is the opposite of the other. Not quite. This is 6mm radius, i.e. there to there is 6mm, and there to there is 6mm, and this is ½ an inch. So that's the diameter being, 12.7, so 6.35. So they nearly fit together, but not quite. Lastly, we're going to talk about how we attach them to the machines, or how we load them into the machines. Now, there's several methods of doing this. Depends on the machine you have. But the machines we use in the student workshop anyway use a quick change collet system. So the tool holder, consists of 3 parts. You've got your main collet there, and this section here slips into the machine. You have the actual collet, and then there's a cap. And these, of course, are used in conjunction with the tool. So to put the whole thing together, we've got, if you can see on the inside of here, there's an offset ring, which you can slide the collet into and clip it round. So from the other angle, it sits in and then clips round. I can then loosely put it on here, like so. Then insert my tool, tighten it by hand, and that will ensure that the center of the tool is always in line with the center of the collet, and therefore the spindle on the machine. Once we're at this stage, we need to tighten it up. So that's what this is. That sits in there, usually held in a vise. And then we have a C-spanner, which tightens the whole thing up. As I say, there are different tools, different methods of inserting tools into milling machines. These are the ones we use in the student workshop, purely for ease of setup and then change of tools. You just need the white path, stick it in, and then it's got a clip. The argument is that it decreases accuracy, which is fair to a point, but it does depend on your own sort of working tolerances. It is possible to remove the whole assembly from the machine and, using a collet directly into the machine, insert a tool and sort of drive it directly. But it's far more time consuming, and it involves using spanners on the top of the machine and things. So this is the most efficient way of changing tools. And that is pretty much all I've got to say about milling machine tools. Thanks very much.